All right, y'all, we have just talked about the different types of functions, and now we're going to be focusing specifically on linear, which we've already learned a little bit about. We've got our equation here, y equals negative 3x plus 4. Reminder that our form that we write this in is y equals mx plus b, where m and b are two very important parts of this function. M is the gradient, or the slope, that change in y over change in x, and the y-intercept is b, where the function touches or crosses the y-axis. Okay, so this is the equation form. This is the one that we have reviewed, but there are multiple ways in which we can represent the same information. Each of them help us understand the equation in a different way. So here we've got y equals mx plus b. Our gradient is our negative 3 here because it is in the m position in our equation. And then our positive 4 here is our y-intercept because it is in the b position. Okay, so hopefully this looks a little bit like review from the past few days. Okay, what we are going to move to next is see how we move from one representation to the other. So if I start in an equation, this is how I move into table form. Okay, so to go from an equation to the table, I'm going to plug in x values to generate y values. Okay, now what does that mean? We're going to be using our equation right here. I'm going to rewrite it at the top. It's y equals negative 3x plus 4. Okay, so that's the equation that we're using for this linear function. Now for your x values, you can choose whatever you want. So choose x values. I always just do 0, 1, 2, 3, 4. But you could make them 8, 10, 12, whatever you want. I always do 0 through 4 though. Okay, so I've chosen my x values. What I'm going to do is plug them in every time I see x to generate a y value. So here I'm taking my equation, y equals negative 3, but where I see x, I'm going to plug in 0 plus 4. Okay, now if I plug that into my calculator, I plug in negative 3, parentheses 0, plus 4, I get 4 as my y value. Okay, because I've gotten 4 as my y value, y becomes 4. I do the exact same thing with every single one of these. I'm going to take my x value, plug it in for x, to generate my y value. So here I'm going to write y equals negative 3, but this time I'm plugging in a value of 1 plus 4. Again, if I plug that in my calculator, I do negative 3, parentheses 1 plus 4, I get 1. Okay? So I'm essentially just going to repeat this process for every single one, where each time I'm just plugging in my new x value. Each time I'm plugging in my new x value. So if I do that with every single one of these, this is my table of values. Okay. Now we can check that this table matches our graph in two ways. First, my y-intercept is 4, when the x value is 0. That's my y-intercept, so my y-intercept is 4. And I know that because it's the slope, I should be changing by minus 3 units each time. So let's see if that's true. To go from 1 to 4, I do 1 minus 4. Whoops, 1 minus 4, that gets me negative 3. So my change between these 2 points is negative 3. Let's see if that's true for these. Negative 2 minus 1 gives me negative 3. So again, my change between these 2 points is negative 3. Negative 5 minus negative 2, again, that is negative 3. So between every single point is -3. Oops, sorry, this is a -8. Forgot a negative here. Sorry about that. Okay, so I know what my next point would be if I did 4. If my next x value was 5, I could say, well, -8, to get from -8 to the next value, -8 plus -3 would give me -11. Okay, -11, and then I would say, okay, does that work when I plug it into my function? If I did y equals -3 times 5, because that's 5 is what I'm now plugging in for, x plus 4. If I plug that in my calculator, it should give me -11. So I do -3 parentheses 5 plus 4 gives me -11. So I've checked that this is correct. The change from here to here is again -3. So our representations should match each other. Okay? Next one is graphing. So to go from a table to graphing, all we do is plot the points. So plot the points. I'll plot this one first. My x value means that I go over 0, so I start at 0, 0, and then I go up 4, so 0, 1, 2, 3, 4. And I've plotted my first point. My next one is 1, positive 1, positive 1, so I go to the right one, then up 1. My next one is 2, -2. So I go positive 2 to the right, and then I go down -2 units. My next one is positive 3, -5, so I go positive 3 to the right, then down -5. Next one is 4, -8, so I go positive 4, so 4 to the right, and then down 8 units to -8 here. And I can see that all of these are related, so I draw my line. Again, my slope and y-intercept should be the same. My slope is the same thing as my gradient, so it's -3. My y-intercept is where it touches or crosses the y-axis, which is at 4. These should match up. Okay, very last thing is how we verbally express this. This first part says the graph of the function contains the point. It can be any one of these points. So I could say it contains the point 3, -5. Or I could say it contains the point 4, -8, because those are both points on this function. And when the value of x increases by 1 unit, the value of y decreases by -3 units. Now, where did this part come from? This part comes from our gradient. Remember, our gradient is change in y over change in x, or our y2 minus y1 over x2 minus x1. So my gradient is this value up here, so I've got -3. I'm going to write it as over 1, so I can see the x change and the y change. So that is for every x increase by 1. So this is 1 x increase. The value of y decreases because it's negative, so -3 y decreases. So this verbal explanation really just describes our slope. Okay, so it is all the same thing. This is all the same function. We've just shown it as an equation, as a table, and as a graph, and explained what each of those mean in words. What I want you to do next is I want you to try this problem on the back. It is exactly what we just did, but with a new equation. So take about 5 to 10 minutes to work on that. Your time starts now.